What is the change in entropy when 1 joule of energy as heat transfers from a large block of iron at 30 degrees Celsius to another large block at 20 degrees Celsius? So let's sketch this out. Say we have a large block like this, and this is going to be our hot block. It's at 30 degrees Celsius, and the heat is being transferred to a cold or colder block. That's our cold one, and that is at 20 degrees Celsius. And 1 joule of energy is being transferred between it. So I'm just gonna, I think that's fine. So 1 joule of energy is being transferred. And they want to know, what is the change in entropy? So the change in entropy, remember entropy can be calculated by saying the heat divided by the temperature. So the change in entropy can be calculated, and that's equal to the heat that's being transferred from the hot block divided by the temperature of the hot block plus the heat that's being transferred to the cold block divided by the temperature of the cold block. Now, the heat that's being transferred from the hot block is losing a joule of energy. So it's going to be -1 divided by the temperature. Now, temperature needs to be in Kelvin. So 30 degrees Celsius plus 273 is equal to 303 Kelvin. So that's going to be 303 plus the cold block is gaining that joule of energy. So it's going to be +1 divided by the temperature is going to be 20 plus 273, which is equal to 293. And that gives us an answer of 1.13 times 10 to the -4 joules per coulomb. Now, the fact that this answer is positive tells us that this is spontaneous, and it makes sense because heat will transfer spontaneously from a hot source to a cold source. Now let's take a look at entropy of expansion. Calculate the change in entropy when a perfect gas expands isothermally. So isothermally means that the temperature is constant, okay, to 10 times its initial volume. So Vf over Vi is equal to 10. Now, you probably know what equation we're going to be using here. The equation is going to be Nr times natural log of Vf over Vi. And they want to know irreversibly against zero pressure. Now, for A, we can say that the change in entropy for the total is equal to the change in entropy for the system plus the change in entropy for the surroundings. Now, the zero pressure is important because we know that delta U is equal to Q plus W, and W is minus P dV. So if there's zero pressure, W is 0. And since it's isothermal, delta U is 0. So Q is equal to 0. If Q is equal to 0, the change in entropy to the surroundings is going to be 0. So the delta S total is going to equal the delta S for the system. Now we can calculate the delta S for the system. That's going to equal Nr times Ln of Vf over Vi. So 1 mole, 8.314, natural log of 10. That gives us an answer of 19 joules per coulomb per mole. Now let's take a look at B. And by the way, this is also going to be equal to delta S total. Now, if it's done reversibly, the delta S total is going to equal 0. So that means that the delta S for the system is going to equal minus delta S for the surroundings. Now again, we can calculate delta S for the system. The delta S for the system is going to equal NR natural log VF over VI. Same things as substituted before, 8.314 ln of 10. That's equal to 19 joules per Kelvin per mole. But the delta S for the surroundings is going to equal minus 19 joules per Kelvin per mole.